All right, welcome back. We're starting another build. We have a lot of builds going on right now. And this one is a KA composite Sabre F5K. So it's a 1.5 meter, kind of like a DLG, but with a motor. And we've done video, like an introduction video on this before. You can check it out. But it's got a really neat wing shape. It just looks different in general, and that's one of the reasons that it piqued my interest. So we're going to go ahead and start this build for a customer, and we're going to start with getting the servos in the wings. And I'll just show you what we're going to be working with. This is a KST X06H, and it is in a 3D printed frame that is supplied with the model. So that's pretty neat. So we're going to use those two things right there, and then this is a bit of wire that's going to make up our aileron drive linkage, also supplied with the kit, and carbon fiber machined control horn there. And the kit comes with the channel for the horn pre-routed and the exit for the wire there. So that makes it really convenient. The first thing we're going to do is try to poke the wire through the wing and get it to exit the servo bay here. And then from there we can position the servo and make the bends and glue the control horn in. The quality is really good. It's got this really neat magnetic wing wiring connector. My only gripe really is, as of now, is the super heavy duty gauge servo wire. They could have used a much thinner wire there, but you know, I'm just nitpicking. So let's move forward with trying to get the wire through the wing. Alright, so the first thing I did just to get ready here is I drilled the two mounting holes for the screws for the servos. These were not pre-drilled in the frame. And to do that, I used my drill with a mini vise or hand drill in the chuck and a 1mm drill bit. Alright, right here you can see both the aileron servos with the horns on them. And I'm going to be using the single-sided horn, and I'm probably going to end up using this tiny hole, the very first hole. But what I did was I put them on the servo programmer and got the arms, you know, identical. So they're all a mirror image of each other. And this is the servo we're going to be putting in this wing here. And you can see the arm is offset. So the arm is offset towards the leading edge, which should make it easier for us to get the flap travel we need, because we don't need a lot of up, but we need a lot of down. So we're going to go with that, and then I'm going to trim up the horn, both the horns, and then yeah, we can proceed. Okay, so we are going to use the furthest hole towards the output shaft, or the closest hole I should say. That little tiny one right there. And that's like, well, I should say that the steel wire supplied with the kit is about 0.76 millimeters. And I didn't have a drill bit to open that up because that hole was too tight. So I just cut a little bit off one of the wires and stuck it in the pin drill, which is stuck in the electric drill. And I sharpened the end to a point, and I just used that to drill this hole there, right there. So that should work out just fine, and it's kind of important because you don't want slop in your linkage, right? You want everything to be pretty tight. So that worked out well. Alright, so I did just poke the wire through, and I put a bend on one side here, and it's in the control horn. The control horn's just dropped in place right now, it's not glued. And on the bottom it looks like this. So what we're going to do is we're going to get the servo in here. We're going to get it on the tester so it's centered to the position that we programmed it to. Then we're going to try to mark this wire and make a bend in this wire. Okay, so I made the bend in the rod here. Before I did that, I taped the surface in neutral, made sure the horn was in place, and marked it with a fine permanent marker and made the bend. Kind of tricky. You could also mark it and take it out and make the bend and try to slide it back in, but the wing's so thin I didn't want to like risk poking through the skins at all, so that's what it looks like. I think I'm gonna have to shorten it up a little bit. It's a little long, so we'll do that. Here's where we're at. Shortened up that bend. Servo fits nicely. So that's basically ready to be glued up. But I haven't done anything to the other wing, so we're gonna get this wing to this state and then we'll glue the servos in. So there's the epoxy. It's thickened up, slow cure resin, and that's that servo. It's got glue on it, it's in place. I have to kind of position it a little bit and put a weight on it. The aileron's taped at neutral, and then if I flip this over, the horn is also epoxied in, so I'm doing this all in one shot, and I think it's going to work out just fine, and I have some tape holding that down, so I got to go ahead and do the same thing to that one. The servos exactly where we want them, and we have some ballast slugs holding them down, so we'll let this cure up overnight. We'll just go ahead and get started on the fuselage while we're waiting for some epoxy to dry on the wing. Here are those really clever magnetic connectors, spring loaded. Kit comes with 3D printed frame, which goes in here in this opening. And these are for X06s with the vertical mount. These guys. So they're going to sit in here like this. So we will kind of see how this servo tray wants to fit in here, and then we'll scuff the fuse up and scuff the frame up and try to get it glued in. It does have some clever notches in it. I'm sure that's there to promote adhesion, which is pretty cool. So let's see how this all fits together. Well, that tray is in there. It's looking pretty good. It's epoxied. I got it in position. It's pretty low. I think everything will work out okay. I got it in position and just tacked the four corners with some CA just to hold it, and then I went over it with epoxy, and we'll let that cure up. And then moving on to the tail of the elevator here, I put a piece of tape down, and I took a ruler and measured the span of the tail and divided that by 2 and made a mark. Let's see that mark in there, right there. And that's going to be where the horn's going to go. And we have 2 identical control horns here, rudder and elevator. So we'll use one of these, and we'll cut a slot in the elevator there. And then we'll take a look at where the rudder horn wants to go. Okay, so I cut the slot for the elevator there, or the horn, and just dropped it in. And it's hitting a little part of the fuselage right in there. So I'm gonna have to clean that up a little bit. Just took the rotary tool with a 1.5mm grinding bit and just kind of came in here and removed some material right in here and kind of at an angle like this to give that horn some more room. Now you can see we get good movement here without any binding on the elevator. So on the rudder, I'm gonna put the horn really far down, really low, so we have about 4mm from the line to the end of the part there. And that's because I want the pull spring to kind of exit around here and not in this pylon, because I want a straight shot through the fuselage to the horn, and I don't want the string to rub up against anything here. and then come out. So we put it pretty low. Again, it's about 4 millimeters from the bottom, from the base of the rudder. There's the rudder horn epoxied in. And we'll just let this and the elevator horn and the aileron servos that we worked on earlier all set up overnight, and then we can continue. Well, I couldn't be more happier with the way this came out. The epoxy's cured, and I took the tape off that was holding the surface centered. And I have the servo tester hooked up here. I'll show you the throws. So we're really getting plenty of down, and just about, well, more up than we need. So that horn selection worked out really well. And I've gone ahead and trimmed the wire coming from the connector here. I took maybe, I don't know, 30 millimeters off of it, and I stripped back the wire, and I'm getting ready to solder on this little tiny connector here, because it's smaller and more compact than a servo connector. And I actually I snipped off a lot of the ends here because it was pretty long, and I just snipped off till I got just enough to solder to, and this is the side that's going to go to the servo. So here's what the pin looks like, the connector. I got it soldered, and I just need to get the shrink tubing up and shrink that down. And I'm not going to use a heat gun because it's just too close to this wing and I don't want to get it hot. So I'm going to use the tip of the soldering iron. I'm going to clean it off with a wet sponge really well, and then I'm just going to rub it on the shrink tubing to get it to shrink down. Here is our crazy crammed servo bay. Got the connector down here. It's really all that it'll go, and the wires are bundled up. I could have shortened the servo wire a little bit, but I'm only going to save maybe half a gram or a gram. So, but it would have really helped if this wire was the same gauge as this. This is like, I don't know, 28 gauge, and this is maybe 22, 20 gauge wire. So that would have saved me a lot of headache if that had thinner wire on it. But anyway, we got it done. And the covers that come with the kit fit really nicely. And the bulge is right in the right spot. So if you get one of these, run the frame all the way up to the edge towards the tip and kind of run it back towards the leading edge. So towards the leading edge and towards the tips is where you want the frame, and the servo cover will fit just perfectly with the, I'm talking about the having the arm in the center of that bulge right there. Last little bit here to finish off this servo installation before we put the cover on is I glued this little bit of plastic onto the sidewall here, and that just prevents the linkage from possibly backing out. See, it's pretty tight up against there, and it's kind of flush with the surface here. And this little piece of plastic was just a little trimming off of a servo ramen IDS kit. Kind of blown through this Sabre build pretty quickly, and I'm enjoying it. Next thing to do is put the springs in the tails, because this is going to be a pull spring setup. So this is a piece of wire they give you. They give you two, so one for the rudder, one for the elevator, and we're going to be putting that across here, and I'll show you how I'm going to do that. Okay, so here's my wire. I basically bent it into a C or U shape like this, and the ends are each 20 millimeters long, and this is whatever distance that is. But I didn't bend them parallel. You see, one kind of is like 20 degrees off from the other one, and you want to do that so the rudder doesn't really fold on itself too badly. And what we're going to do is put this across here kind of equal distance, right? So we're going to have to poke a hole. We're going to have to do some measuring and poke a few holes. So here's what I got. You can see my little gold dot there, and I have one there, and the spring is inserted into the moving part of the elevator and the fixed part, and this is kind of how it naturally wants to be. And I did put a drop of CA over this and over this, well, maybe 2 drops on each point, just to try to harden that area up a little bit. So the next thing to do is going to be to get this on the fuse and run the string. Okay, so this is the wire supplied with the kit, and you can see this little piece of tubing. 4 of these are also supplied, and I've just slipped the tubing over the wire and then kind of routed the wire back in to make this loop right here. And that loop is going to attach to the horn, because the horn is slotted. So what we're going to do is crimp this tube, and also at the same time put a drop of CA on it. And there's the crimped tube, and I put a drop of CA kind of where that loop is and let it soak in there as well, just for a little bit of extra insurance. I don't know if that'll actually do anything, but I always do that. So now we can get the tail mounted on the fuse and run this string through. Alright, so we're in the fuselage, and I've put the horn on. Again, I've used the tiniest horn, single-sided horn. I have the servo plugged into the tester, so it's powered on because we don't want it to move. And I was able to hook up the pull string like exactly the same way we did on the tail. I ran it through the arm, and then or I put the sleeve on. Then I ran the string through the arm and ran it back through the sleeve, and I got a pair of these hemostats, clipped one end and then just rolled the wire around the tip of the hemostats a few times and just pulled until the tail was fairly neutral. And kind of with one hand I was pulling, and the other hand I had a pair of needle nose, and I was able to crimp the tube there. So that's the elevator done. We're going to do the rudder exactly the same way. So we wrapped up the installation of the servos and the fuselage there. Came out really well. Rudder, elevator. Both have the shortest horns or arms. And then on the rudder, let me show you what I got here. Same exact thing at the horn. We made that loop and crimped it, and then it exits kind of right where the vertical starts here. But I got a little piece of plastic tubing and insert it there like a bushing, and then just kind of sanded it kind of flush. Ooh. Kind of flush with the fuselage there. And that just kind of that's going to protect the fuselage, because if you just had the cable coming out, it would kind of start tearing up the carbon and eventually just make a slit, a real long slit, and damage your fuselage. So always good to put a bushing in situations like that. All right, trudging along, just got the servo cover taped on to one wing, just using some clear tape around the edges. Fits quite well. So we'll do the other wing, and then we'll basically be totally done with the wings. So the last thing we need to do on the Sabre build is basically get the motor installed, and so I'm working on that right now. I have here a 1507 T motor. It's a 2700 kV. Here's the box if you want to look at it. Right there. And it's on the 3D printed mount that comes with the kit. And I think this is going to work out really well. I just want to point out a few things. Firstly, that center hole where you see the shaft and the E-clip, that wasn't in the part. So I had to drill that out to get clearance for that. Not a big deal, but just keep that in mind. And then the screws came with the motor. And I had some washers that I put behind the screws or underneath the screw heads, just because the regular PLA 3D printed parts can compress slightly, so you want to be careful. The washers just gives us some more surface area, and I did put some medium strength thread lock on the screws, and then I tightened them, and I just kind of didn't crank them down a ton. When they got snug, I just kind of stopped there, because you don't want to compress the plastic, and the thread lock should, keep everything in place. And then we're going to use this CCM 25mm spinner. This is the one for the 5mm threaded shafts on these motors. And here's the hub, or collet, or whatever. And here's the spinner cap. And this metal piece is threaded. This is also threaded, and I'll show you how this goes on the motor. But basically this is going to go in the motor like that. And you can see the mount is the same shape as the inside of the fuselage. And there's a channel there for the wire to pass through. So I have sanded the inside of the fuse with some coarse sandpaper where this is going to mount, and cleaned it with some alcohol, and we're basically ready to install this. I got to think a minute about how to hold it in place while the epoxy cures, because it can just kind of wobble around a little bit. Okay, so I think I've come up with a solution to help me get this motor mounted in or glued in and keep everything aligned really well. My 3D printer is going on in the background and it's pretty close to me, so I apologize for the noise. But I've made 2 rings. You can see them both here. They have a lip on them. Both of them have a lip. So one is basically straight, like a straight recess, and the spinner fits in it like this. Okay, real tight, fits well. And the other one has a taper to allow for the taper on the fuselage, and that goes over the fuselage like that. And the idea is I'm going to actually glue them together back to back like that. And that'll allow me to kind of use them as a spacer to tape the spinner onto the fuse and force it against the fuse while the resin's drying for that motor mount. And that should hold everything in perfect alignment. So I glued these 2 rings together, and I'll just show you what it's going to look like. We're going to slip the tapered side over the fuse, and then the spinner will go into the other side like this, and then we can push really firmly backwards, which will be with masking tape, and see everything well and keep everything concentric. I got epoxy, 30-minute epoxy mixed up and applied on the inside of the fuselage there. And now I'm going to slip that motor in. Well, this seems to be working pretty well. I didn't even have to use masking tape because when I tighten the spinner, it kind of just sucks it down against the motor and the fuselage, and there's force being applied that way. So it's real tight. So I'm really happy with that. We'll see how it comes out when it dries. I taped the wire up just so it wouldn't get epoxy on it. You probably won't be able to see it in there, but that's the motor wire, and I just taped it up like that so it wasn't laying against the bottom of the fuselage to try to keep it off the epoxy. And yeah, that's about it. That's the last step, really. I gotta put the speed control in, but you don't need to see that. But after this is dry, we will put the prop on there, and we'll be just about done. Well, I've got the props on, the spinner, it's all buttoned up. Got the Castle Talon 15. It's kind of shrink wrapped to bundle up some of the wire, and then it's double-sided taped to the side of the fuselage there. And we'll leave it up to the customer to do what he wants with the wires and get the battery in. I am providing him a Tattoo 550 milliamp 2S, claimed to be 95C, but that's probably BS. And I did run this up on a watt meter. So just for your information here, this T-motor 1507 2700 kV with a CCM, not CN, CCM 7x4 prop. how great that fits. That pulled static 14 amps and just about 100 watts. So in the air it's going to be less than 14 amps, maybe 12 or 13. Just, I think, perfect setup. Tons of thrust. Didn't put it on the thrust gauge, but feels super strong. So there we go. It's a nice little build. Pretty happy with the way everything came out. I'm going to be building one of these for me in the near future. This one's going out to a customer. Looks really cool. Hope you guys enjoyed, and if you're thinking about a Sabre or building a Sabre, maybe these videos will help you out along the way with the build. One thing I did want to mention was that my gap here between the spinner and the fuse was a little bit bigger than I liked. Next time I'm going to thin out those 3D printed pieces a little bit and try to cut that gap in half maybe, but everything fits so nicely. I'm so happy with that. Alright, enough. See you guys later, and hope you guys enjoyed. Bye.